Hi everybody. Welcome back to Algebra 2 online. As we are moving through here, we're into week 2. So you can see I'm trying to keep you organized. We're into week 2, and this is our first concept, which is concept A, and this is video number 1. We are going to be, I'm going to be walking you through some things for this time your practice problems. We are not going to use Khan Academy. We are going to use some teacher-made practice problems that you will be able to find online using your resources, whatever those are. I'm not really sure at this point. I'm getting the videos done ahead of time. So you're going to do a couple teacher-made practice problems not on Khan Academy today when dealing with our next topic. So the big question is, I know you've all been waiting for, is what do you do if you don't have a right triangle? So last week we talked about if we have a right triangle, then we know we can either use Pythagorean theorem, a squared plus b squared equals c squared, or we can use our newly beloved trig ratios because we're dealing with a right triangle. Okay, well, what happens if we don't have a right triangle? Oh my. What happens if we are given a triangle? I'm going to draw a really generic triangle. Be warned. And let's say this time, triangle ABC is not a right triangle. Let's say that instead, I know that this is a 42-degree angle, and I know that this side is 10. This side is slightly smaller, let's say 8.5. Okay, and let's say that I would like to find this angle. Here's my question mark. I'm looking for the measure of angle C. Oh my. Okay, well, we know that if this side is 10 and that's 42 degrees, then this one is going to have to be smaller. So what mathematicians have discovered is that there's a different law, and next year, if you guys go on to pre-calculus, you will derive this law and you will prove that this law works. But for now, especially in our remote learning phase that we're in here, we are going to be simply throwing this law right at you. So the law says, this law is called the law of sines. And what the law of sines does is it says if you don't have a right triangle, no big deal. Mathematicians have proven and they've discovered that this relationship works no matter what. And the relationship says that the sine of A divided by the corresponding side, which would be little a, is equivalent to the sine of B divided by little b, which is also equivalent to, you guessed it, the sine of C divided by side C. And that this law of sines is true for any triangle. Now, the law of sines can be written with these ratios, and the law of sines mathematically then will also hold true for the inverted ratios, which means it would look something like this. Okay, so here's your law of sines intro lesson. Okay, so we are looking at corresponding sides and angles. I'm going to come back to this one in a little bit once we talk through this. And what I just want you guys to practice with today is simply the mathematics behind solving an equation which is set up to be two equivalent ratios. So kind of our intro problem here is going to be, what if we know that angle A is 43 degrees? What if we know that angle B is 52 degrees? And what if we know that little b, or side B, is 20 units long? Okay, well, what I'm noticing about the law of sines is that corresponding angles and sides are going to be very important. So I can see that I have what's called a complete pair. So this is my complete pair that I look for because I know that I have one of these completely, which means that big A is part of an incomplete pair. Who are we missing? If we have angle A, we could definitely find little a. And one thing that I like to do, which is why I've got this intro, is I like to set up my triangle because, as you guys know, I'm not big into drawing pictures, very algebraically minded. I'm going to set up my triangle like this, where I've got corresponding angles and sides. And this is going to help us all week long here. So if I have big A, I can fill that in at 43 degrees. I also know that angle B is 52 degrees. And I also know that little b is 20. Here's the thing I'm missing. So I really like to utilize this graphic organizer to show me that I've got a complete pair here, which means that law of sines is going to be something that I am going to be able to use. And if I have a complete pair, I can definitely use law of sines. Okay, so let's try to solve this one. So as you can see, we have two different versions of law of sines, and I usually like to use the one where whatever I'm missing is going to be in my numerator, because that's going to be a lot easier to solve. When we have an unknown in the denominator, it makes our life a lot more difficult. So I'm missing little a, and I have a complete pair, which is my b's. So I can basically just ignore this entire C situation. I don't know anything about C, and I'm not really being asked to find C, so I'm gonna just ignore it. All right, so here we go. I'm gonna set up my law of sines. Law of sines does not need a right triangle. So what I don't know is I don't know little a, but I do know that I can divide by the sine of 43 degrees. And that is going to be equal to little b. I'm just substituting in my givens divided by sine of 52 degrees. So you can see now I've taken this equation and I've whittled it down to one unknown. Okay, well, if I'm trying to isolate A, I need to undo whatever is being done to A. So right now I am dividing by the sine of 43 degrees, which we know is a number. Well, how do you undo dividing? Multiplying. So I'm going to multiply this side by the sine of 43. Okay, which means, because I'm dealing with an equation, I need to multiply this side by the sine of 43. Well, sine of 43 divided by sine of 43, that was the point. So now I've got little a is equal to this entire expression, which means in one little quick multiplying, I'm set. Here I am setting up my test mode. I'm set to figure out what little a is going to be. Okay, so I need to input this expression into my Desmos. So I've got 20 times sine 43. And what am I going to do with that? I'm going to divide it all by the sine of 52. So I'm going to divide it all by the sine of 52 degrees. And there I am. This is telling me that little a is going to be 17.309. Now on this particular one, let's go out to the nearest tenth. So I'm looking at just 17.3. So I'm going to go back here in my graphic organizer, and I'm going to say that that's 17.3. I love the graphic organizer because I can tell that I'm probably right. 52 degrees is bigger than 43 degrees, which means that the side of 20 has to be bigger than the side of little a. So that's how you're going to find little a. That's one option. Another option is going to be going back up here, where the mathematics in this one are going to be a little bit more challenging. So I'm going to continue down here. Here was my triangle. And now today we're going to kind of work outside of triangles. We're just going to work with these graphic organizers. So let's say this time, I'm going to throw number 1 down here. I'm going to set it up into my graphic organizer. Get it out of the picture and into a more algebraic format. So angle A is 42 degrees. I know that little a all the way across is little a. I know that little a is 10. I don't know angle C. That's what I'm missing. And I do know that little c is 8.5. So for today, we're going to keep the pictures out of it. We're just going to stick with our information. Okay, so here we go. Law of signs means I am looking for a complete pair. Here's my complete pair. And what don't I know? Well, what don't I know is right here in C. Okay, so I'm going to keep the unknown in the numerator, which means this time I'm using this one. And it looks like I'm using C's and A's. Okay, so I'm going to start with my unknown. Remember, an equivalent expression, I can do whatever order I want. So as I set up this one, I'm going to start with my unknown, sine of big C, so here I am, divided by corresponding side, 8.5. is equal to, now I gotta do this one in the same order. So this time my angle's on top. Sine of 42 divided by the corresponding side, which is 10. All right, so we don't have too much experience with solving equations like this. It's been a while. So as you can see, this one is a little trickier because my unknown isn't quite as simple as this one. This one we only had to undo one thing. This angle C is buried. So the first thing we can undo is that 8.5. Same process as above. How would you undo divide by 8.5? Multiply, inverse, which means on this side, I'm going to keep sine of 42 here. I've got my 8.5 multiplying. Okay, well now, I better write this down, a separate step. You don't really need to, but you can. So now I've got sine of C is going to be the sine of 42 times 8.5, all divided by 10. Don't do this yet. We can save all this. You guys are getting to be really great mathematicians this year. So now the thing that I need to undo is, this brings me back to last week, I need to undo this sine. How do you undo sine? Oh, of course, inverse sine, which means I need to take, this is where I'm going to get a little messy, I need to take the inverse sine of all that stuff. Oh my gosh. Okay, so let's throw this thing into Desmos and see how this works. So I'm going to X out here. Okay, the way that I like to do this personally, you guys can get your own way, is I like to input all of this first. So I'm going to input sine of 42 times 8.5, whoops, 8.5. Okay, there's my numerator, sine of 42 times 8.5. I'm going to divide the whole thing by 10, and this is going to take some practice. Now, I've got 0.56876. This is not an adequate angle measure. I know that that's not going to be the answer. And what I need to remember is that now I need to take the inverse sine of this whole thing without rounding first. So I'm going to tap in front, and I am simply now going to throw my inverse sine in front, just like I did here when I was solving. So I'm going to take the inverse sine of that whole thing, and Desmos will automatically throw your parentheses in there for you. So if you just save that inverse sine for the very end, now I've got a decent angle measurement, which is 34.6 degrees, 0.66 degrees. So now I'm going back into my organizer, 34.66 degrees. Does that make sense? Well, 42 is bigger than 34, which means that little a needs to be bigger than little c, and in fact it is. Awesome. So today, your practice problems are going to be listed not as a triangle, but your practice problems are going to be listed in terms of a list that looks like this. And you're going to have 4 practice problems, 2 of each, just to make sure that you can get a little practice solving algebraically before we throw it into a triangle. Okay, good luck.